Good morning. Welcome to your Tuesday edition of Cup of Cyber. I'm Jim Broad. As always, enjoying a lovely cup of illy coffee today, surrounded by the Missouri Show Me Cup. Always good to start with a cup of coffee when we start talking about the Tuesday topic, NIST controls. So, a lot of times we are faced with the situation where we've got different types of information on the same computer system. So we've got maybe a large system that's made of several servers and several different computers. And we have different levels of data on that system, right? So maybe we have personally identifiable information, or we have healthcare information, or we have even just different types of sensitive information. So maybe we've got company proprietary information or research and development information. And one way we can go about securing that system is to secure the entire system, right, at that level. So maybe we have something like PII or PCI, so personally identifiable information, or payment card information, stuff like credit card data. So one way we can go about this is we can take the entire system and make the entire system secure at that level. So we know as we apply controls cost money. They cost money, they cost time, they cost resources. You have to add extra equipment a lot of times. So if we apply the controls to the entirety of the system, it may prohibit not only the development of the system, because maybe it'll be too expensive, but it may also prohibit who can use the system. So maybe they're not cleared to look at that privacy information, or maybe they're not cleared to look at that payment card information. It becomes worse if we're looking at systems like government systems that have things like confidentiality levels, confidential, secret, top secret. Getting people cleared to those levels is obviously expensive, and sometimes people just can't be cleared to those levels. So maybe you don't have enough people to work on that system. So one way we can go about dealing with this, right? We can compartment our system out, right? We can say that maybe the PII components are only going to be in this part of the system, or this system will be top secret and this other system will be secret and this other one will be unclassified. So this control we're going to look at today, AC-4, has implications not only in the government, but in the connections between secret and top secret and confidential and not classified systems, but also in the civilian market and the non-government world. When we talk about maybe a system that has PII on it, or PCI, or healthcare information, or any other types of information we want to segment out. So this is the control we can use to provide information flow control. So that's what this one is. It's AC-4, information flow enforcement. The controls defined as the information system enforces approved authorizations for controlling the flow of information within the system and between interconnected systems based on, and again, like when we see that square bracket, we know that there has to be an organizationally defined variable we have to put in there. So the organization has to define what are the information flow control policies, right? So in the government, we can say that can be fairly easy. We could say that information at the top secret level cannot flow to the secret level, because that would break a bunch of things, including with this flow control we said here. We may also say that information at the secret level cannot flow to the top secret level. And you may say that's kind of weird. Why would you want to, why would you restrict data from secret to top secret? Well, maybe that secret level data is not 100% accurate. Maybe there's some pieces missing, and you don't want that at the top secret level, so that the people at the top secret level, when they read that data that's developed at the secret level, maybe there's pieces missing. So what we're trying to say is that if you're at the top secret level, you should be reading that data if it's available at the top secret level, right? So if we read it at the secret level, at the top secret level, can have the possibility to read down into the secret level, but we need to be aware that we're reading secret level data, right? So that's a little more on user roles and mandatory access control rights more than information flow enforcement. But we know we have to build these boundaries around these systems, and information flow enforcement is kind of what we build those boundaries with, right? So I'm a little bit over the side here, this so that we can fit all of this stuff in here. So supplemental guidance for AC-4, and this is really going to define what this control is all about. Information flow control regulates where information is allowed to travel within an information system and between information systems, as opposed to who is allowed to access the information. So we're not talking about the people or the rights of the people or the users that are accessing this information. We're talking about the information system itself. Is where can the data move to within this information system, and without explicit regard to subsequent access to that information. So when we set our information up, or our flow control up, we're worried about where it's moving around in our system and not where it moves after we make these flow controls, right? So if we say it's flowing from component A to component B, and we control both those two components, and this is the information flow we're diagramming and we're creating the rules around, we're not caring where it goes to after B, right? We're going to have controls in place that will prevent that information from traveling outside that area B if it's not allowed to, but we're not worried about it beyond that point once it goes to a authorized place, right? Flow control restrictions include, for example, keeping export controlled information from being transmitted in the clear on the internet, blocking outside traffic that claims to be from within the organization, restricting web requests to the internet that are not from the internal web proxy server, and limiting information transfers between organizations based on data structures and content. So a lot of pieces in that sentence, right? Export controlled information. So we want to make sure that if there's export controlled information, something like a lot of times we can't transfer encryption technologies outside the United States. So if that's going outside our organization, we want to make sure that it's not being transmitted in the clear on the internet. So we're using encryption technologies usually to protect that. We're making sure that we're blocking traffic on the firewall that claims to be being initiated inside the organization. So we shouldn't have anyone with an IP address that's inside our organization coming from outside the firewall. So if we see that, we want to block that. Obviously, we've all seen this one, restricting web accesses to different sites like porn sites or hate sites or stuff like that. But this one we're saying, if someone's trying to access a website outside the proxy, we're going to block that too. We're going to say, if you're going to a website and you're trying to get information without going through the proxy, you're not going to get to it. We're going to keep that information from getting to you, and probably keeping the information, the request, from even going out. So we're controlling the flow of information, right? And then obviously the data structures. DLP has been a big thing, or data loss prevention or data loss protection, depending on what house you come from, has been a big thing to help us kind of define the rules around this. So if we have something like credit card information, and we don't want that to flow outside of the area where we've got our payment card processing, the area of our network that's protected for payment card processing, we can set up a DLP solution that says, as you cross that DLP solution, if you have credit card information, the DLP solution will stop it from going, right? We see this in the government with protections on cross-domain solutions where we can't push top secret data to a secret system, right? Transferring information between systems representing different security domains with different security policies introduce risks that such transfers violate one or more domain security policies. in such situations where owners or stewards provide guidance at the designated policy enforcement points between you and interconnected systems. So we have data owners and data stewards that are responsible for those levels of data. We'll see that at the top secret level, the secret level, but we also see it, like sometimes HR is responsible for PII because it's a lot of PII lives in the HR realm. So the HR may be responsible for all of that. So they may say, hey, at the point your system can process PII, but at this point when it's leaving your information system, you need to put a DLP solution. Or you're processing this specific type of top secret data, and at this point you need to put a cross-domain solution or a boundary protection device to keep that information from flowing outside of your system into the other part. Organizations consider mandating specific architectural solutions when required to enforce specific security policies. Enforcement includes, for example, prohibiting information transfers between interconnected systems. So you're only allowing access from the outside, and the information can't be transferred, right? Employing hardware mechanisms that enforce one-way information flows or one-way transfers, and implementing trustworthy regrading mechanisms to reassign security attributes and security labels. Labeling is pretty important if we want to do this correctly. So we want to make sure that if we're having a trustworthy regrading mechanism, that's going to normally be manual review is the best way to do that. But I'm sure things change over time. So we can have a way to downgrade information. So it can be top secret information that gets put on a secret system, but it has to be regraded. And there's got to be a way to trustfully do that, make sure that all the correct information is removed. Same thing for PII. So if we're moving PII from a PII zone to another zone in the system, we need to make sure that that is obfuscated enough to where it's no longer PII, right? And we obviously change those security markings, those attribute labels, right? Cool. And it goes on. Organizations commonly employ information control policies and enforcement mechanisms to control the flow of information between designated sources and destinations. So they're saying networks, individuals, and devices within the information system and between interconnected systems. So again, we can have this within our information system. We can have a part that is zoned out that's going to be our area that's PII controlled or PCI or something like that, whatever kind of different designation we have for that zone. But there's got to be protections around it, right? Flow control is based on the characteristics of the information and the information path. Enforcement occurs, for example, in boundary protection devices like gateways, routers, guards, encrypted tunnels, and firewalls that employ rule sets to establish configuration settings that restrict information system services, provide packet filtering capabilities based on header information, or message filtering capabilities based on message content, implementing keyword searches or using domain characteristics. Again, we see that a lot with so things like dirty word searches, where we look for different words in a message, right? I worked at a financial brokerage house, and they could not, as a broker, you cannot guarantee that a client is going to get a specific rate of return. So we had a system in place that would check all email for specific dirty words, right? It would look for things like guarantee or promise, and it would flag those emails going out. And then some manager would have to review the email and make sure that a broker was not promising a client a specific rate of return. So the keywords, those dirty words, are set up, and they're usually kept fairly private. And then someone has to go in and manually review all the things that meet those same requirements. So we have obviously you can have the same thing in trusted systems and government systems. The other thing is DLP solutions do this kind of, there's a set generally in DLP solutions that come kind of standard with any of them. So if you see something that is number, dash, number, dash, number, this format of a social security number, the DLP solution can kind of guess that this might be a social security number and it might be PII and should be protected. Or if it sees a string that looks like a credit card number, that DLP solution may out of the box say, hey, this looks like a credit card number. Maybe it shouldn't leave our PII area, right? So we can look on those different characteristics of the data itself, or maybe it's some type of manual review. Organizations also consider the trustworthiness of the filtering inspection mechanism, hardware, firmware, and software components that are critical to information flow enforcement. Control enhancements 3 through 2022 primarily address cross-domain solutions needs with focus on more advanced filtering techniques and in-depth analysis and stronger flow enforcement mechanisms implemented in cross-domain products. For example, high assurance guards. Such capabilities are generally not available in commercial, off-the-shelf information technology products. And then we have our list of related controls. This morning, I just want to go over Enhancement 1 and Enhancement 2 because 3 and 22 are really focused at government use. They're focused at cross-domain solutions. And I think it's worthwhile to set up a separate talk where we just talk about cross-domain solutions, one-way transfers, and guards. So in that talk, we'll talk about Enhancements 3 through 22. If you're not working in an environment where you're at the top secret level or the secret level, where you're implementing guards, one-way transfers, and cross-domain solutions, you'll probably never implement those enhancements, right? And as you can see, AC-4 by itself, it's a priority 1 control, so we do it amongst the first things we do when we build a system. Not that it is more critical than anything else or it's more dangerous than anything else. It's just in the programmatic building of a system, this can be one of the first ones we do. If we have a low baseline system, this is not selected by NIST, and it's selected just the base control, just AC-4, the control we just talked about, at the moderate and high level. The 2 enhancements we'll talk about this morning, Enhancement 1 and Enhancement 2, will be selected if you need to add them in during the tailoring process, but they're not required at any NIST baseline, right? So they may be required based on a local baseline at your organization, or they may be required because you're a intelligence community system or a DoD system. But for the pure high watermark baseline, that is the generic NIST baseline, AC-4 is only required, the core control itself is only required at the moderate and high level. And if you have a low impact system, it's not required at all. Obviously, can always be tailored in, and enhancements 1 and 2 can be tailored in as well if you need them. So let's take a look at them. AC-4 Enhancement 1, obviously information flow enforcement, object security attributes. And here we have another opportunity where we have some organizationally defined variables, right? So the information system uses, and we're going to have, the organization has to define some security attributes, right? So it may be a marker, it may be some type of marking within the header of the information, associated with, and then we're going to have another defined variable, organizationally defined information sources, destinations, and objects. So we could say, you could have that marker associated with PII information, right? So maybe we have a marker in the header that's going to identify PII information to enforce, and then the last variable in this one, organizationally defined information flow policies as based on flow control decisions. So maybe we're going to say that PII information cannot leave that PII part of the network, right? So we've got part of the network we're going to protect at the PII level. That means for the person building the system, we only have to put those PII controls within that subsystem, within that subcomponent of the larger system. So maybe we have 50 computers in that area and we have 1,000 in the rest of it. We only have to apply those PII controls to those 50 systems because we have a protection system around that information where we're ensuring that PII information will not flow to the rest of the system. So supplemental guidance on this one, information flow enforcement mechanism, compare security attributes associated with information, with that data contained and data structure, data content and data structure, and source destination objects and respond appropriately, block, quarantine, or alert the administrator when the mechanisms encounter information flows not explicitly allowed by information flow policies. And again, we're going to set a policy that says if you're PII, you can't leave that domain, right? You can't leave that area of the network. So what happens when that information, someone tries to move that information out, that's going to be dependent on the policies. Does it block it? Does it quarantine it? Does it alert an administrator? We've got to define those things, right? For example, an information object labeled secret would be allowed to flow to a destination object labeled secret, but information labeled top secret would not be able to flow to a destination object labeled secret. We're just saying that top secret or that PII information can't go to an area where it's not approved to be at. Security attributes can also include, for example, source and destination address, encrypted traffic filter firewalls. Flow enforcement using explicit security attributes can be used, for example, to control the release of certain types of information. So really, we're defining where information can flow in our information system. If we have restrictions on that information where it can flow, we're gonna write policies, and we're gonna keep it quarantined in certain areas. We're gonna keep it bound up in areas, and this is the control that does that. And then finally, our last enhancement we're going to talk about this morning: information flow enforcement processing domains. The information system uses protected processing domains to enforce, and then again we've got our organizationally defined variable. Organizationally defined information flow control policies. And again, we're going to set a policy that says maybe PII can only be processed in this processing domain. So we're going to set a specific domain up that is just for information processing of that PII information. Same thing if we're talking about top secret or whatever. Whatever that information we're trying to segment off from, we're going to only process it within this processing domain. So we're going to set a specific domain up that is going to be only for, say, top secret data or for PII data. Within information systems, protected processing domains are processing spaces that have controlled interactions with other processing spaces, thus enabling the control of information flows between these spaces and to and from data and information objects. A protected processing domain can be provided, for example, by implementing a domain and type enforcement. In domain and type enforcement, information system processes are assigned to domains. The information is identified by type, and information flows are controlled by and based on allowed information access determined by the domain type. Allowed signaling among domains is allowed to process transitions to other domains. So we're saying that one domain would be set up for processing a specific type of information. The domain can signal and talk to other domains, but the information shouldn't flow there if that's not approved. That's not an approved connection. So AC-4 is a good control. We're working through our access control, right? There's a ton of additional enhancements within AC-4. And again, they're generally used for cross-domain solutions, one-way transfers, government systems, usually. So, hope the day finds you well. As always, like, subscribe, comment, hit the bell to be notified. Love to hear what you want us to talk about more. But I hope you enjoy your day. Get out there, be safe, and we will see you tomorrow morning.